Consuelo, once again, mathletes, it's time for the great world of mathematics in your life. Okay, today we're going to do a little bit more on factoring. It's really just an extension of what we've done before. Remember, I said the two things you're looking for. Number one, greatest common factor. Number two, difference two squares or a trinomial. We're going to be looking at a greatest common factor, but it's something we've kind of done, but just maybe taking it a step further. Okay, so let's take a look at number 1 and 2 we've already done before. Okay, so what's the greatest common factor here at z? Again, very important, write down the z first, the greatest common factor first. And what happens when you pull out the z, you get x minus 1. Okay, same idea here. There are two terms, but what is the greatest common? So here's the first term, here's the second term. What's common to both those? X minus 7. Write it down first. And what happens after you pull an x minus 7 out of each of those? You get x plus 1. Again, this is not new, but you need to understand this in order to understand what we're going to do today. Okay, so when do you start doing what it is we're going to do today, which is factoring by grouping, okay? So it's more on factoring, a binomial greatest common factor, and we're going to do this by grouping. Okay, when do you do this? Usually when there are 4 terms, okay? So what we're going to do is group the first 2 together and group the last 2 together. Now, you could put parentheses around this, and quite frankly, putting parentheses is technically what you should do, but I want to show you something. Okay, what do people do when they put parentheses? They do this. They put parentheses there and parentheses there, and that's wrong. Okay? So what should you be doing? You always have to include this sign right here in the second set of parentheses. So what you do is put parentheses around this and parentheses around that. The only problem is these are now multiplied instead of added. So what you'd have to do is add. At this point, people kind of start getting confused and they go, well, what difference does it make? I'll show you what difference it makes. We'll come back to number 3, but look at number 4. Let's say you do what most people do. Put parentheses around the first 2, parentheses around the last 2. You've just changed the problem. Because take a look at the original problem. The original problem is negative 7x plus 35. But if you put the parentheses here, that means negative 7x minus 35. So what you have to do, if you're going to use parentheses, is this. You have to put parentheses around the first 2, and then always include that sign, and then put a plus between them, okay? That's why I did it this way on number 3. Okay, and it may seem pointless on number 3, but again, what I'm always trying to do with you is build up a habit, a good habit. Hopefully we're building up good habits, okay? So that is technically what you should do. Myself, probably what I would recommend, although I'm not, believe me, there's nothing wrong with putting parentheses. It's a very good thing. But probably what I'd do is I would underline the first 2, and underline the second 2, including whatever that sign is. So if you take a look at number 4, I underline those 2, and then underline those 2. That doesn't mean I'm multiplying them, okay? All right, now here's the idea. What can I pull out of the first 2? And hopefully you can see there's an x squared. So that would give us x squared times x minus 7. Now, what can I do with the last 2? Well, really nothing, so I'm going to put plus the quantity x minus 7. I want to point out something. We have not factored. It's not like we can factor more. We have not factored at all. Because factoring means pulling apart into things that are multiplied. And I've pulled this apart, but I've pulled it apart into things that are added. So we have not factored anything so far. Make sure you understand that. Okay, so let's take a look at this then. So we haven't factored anything. All right? So let's look at it. Greatest common factor, difference two squares or a trinomial. Is there greatest common factor here? Yeah, there's an x minus 7. And then what happens after I pull out an x minus 7? I get x squared plus 1. This is virtually, I mean, there's one slight difference, but this is virtually the same as problem number 2. Pulled out the x minus 7, and then I said, okay, what did I have left over? Okay, now you should always look to factor it again. So like here we have this x squared plus 1, but it doesn't have a greatest common factor. It's not a difference of two squares or a trinomial, so we're done. Again, you should never be looking at this, gee, what can I do? What you should be looking at is saying, number 1 is their greatest common factor. Number 2 is the difference of two squares or a trinomial. Okay, let's take a look at number 4. What do we have in the first two terms of number 4? An x squared. That leaves us with x minus 5. Okay, now what do we have in the last two terms? You could say there's a 7, that's true. But watch what happens if I pull out a 7. I get negative x plus 5. And notice these are not the same. Well, we want those to be the same. We want it to be a greatest common factor. So what I'm going to do instead is pull out a negative 7, leaving us with x minus 5. Now, is our greatest, so again, I still haven't factored it. We still have terms here. So I'm going to pull out the x minus 5 and always write that first. And that leaves us with x squared minus 7. Again, on this x squared minus 7, there's no greatest common factor there. There's no difference of two squares or trinomials, so we're done factoring it. Okay? All right, next. Let's take a look at the first two. Then take a look at the last two. So let's pull an x out of the first two, and that gives me x plus y. Let's pull a negative z out of the last two, and that gives me x plus y. Again, we haven't factored it because this thing's being subtracted. We're kind of just setting it up to be factored, that's all. Okay, so now we have an x plus y is common to both of them. And if we pull out an x plus y, we get x minus z. Okay, that's factored. All right, here, what can I do? I can pull out an x cubed. So here's the first two terms, here's the last two. I can pull out an x cubed, and that gives me 2x minus 9. Then I can pull out a negative 5, and that gives me 2x minus 9. Again, I have not factored anything yet, but notice I have a 2x minus 9 in common. And if I pull out a 2x minus 9 out of each of these, I get x cubed minus 5. And again, there's no greatest common factor with what's left over. There's no greatest common factor. There's no difference two squares or trinomial, so we're done. Okay? If I'm not mistaken, that's the last problem. That is the last problem. So if you have any questions on it, please ask.